Hello everyone, as you all know that I am your science expert, and today in this video we are going to explore the very interesting topic, and the topic is chemical reaction and equations. Right, so in this chapter we are going to cover many subtopics. So let's have a glance at what we are going to cover in this interesting chapter. So what we are going to do is, we are going to study about the introduction of chemical reaction. Secondly, we will take up the characteristics of chemical reaction. Third, we are going to study about the types of chemical reaction. Fourth, we are going to study about redox reaction and its application in daily routine. So these all topics we are going to study in this chapter. So before starting, let me introduce to you that what actually we are going to study in this chapter. So you must have noticed that we come across lot of chemical changes around us. So let me specify that what we exactly mean by saying the chemical change. As we have studied in the 8th class also, that we come across lot of changes, and we can classify those changes into two categories, that is a physical and a chemical change. So if I talk about the physical change, so the physical change is something in which no new substance is formed. Like if we are melting ice, so we know that the composition of ice is H2O, and if I melt it, it becomes water, but the composition remains same as its chemical constitution remains same, that is H2O. So that means no new substance is formed, only the state is being changed. And if we talk about the physical changes, the changes are reversible. That is, we can convert ice into water, water into vapor, vapor into water, or water into ice. We can do anything. So that means the changes are reversible, right? So next, if I talk about the physical change, there is no energy changes that takes place. There are no as such energy changes that take place in the physical change, right? But if we consider the chemical change, in that new substance is formed. Now you must be thinking that like how the new substance is formed, or you must be thinking of certain example. So there are a lot of examples which you come across. You must have noticed that if somebody like comes to your house, then what do? You prepare tea, coffee, right? So what do you do in that? Like if your mother is preparing tea or coffee, so she takes milk, she takes water, she adds tea to it, she adds sugar to it, and finally the product is there, that is, they all combine and form tea, right? That means something new substance is formed in that case. Another example, like if you bring some article, iron article like from market, you know that initially it is lustrous, it has a shine, but with time what happened, the shine fades away. That is a chemical reaction. One more example, like if your mother wants to prepare cheese, like if you want a homemade cheese, how it is prepared? Obviously, your mother prepare it from the milk. Right. So what she actually does, that she keeps the milk in the pan and starts heating it. Right. And then you add few drops of vinegar or a lemon juice into it. And then after some time we see that the whole of the milk is changed into the cheese. So that is the homemade cheese. So that means the milk no longer remains the milk. It has turned to cheese now. So again, this is a chemical change, right? So that means all the changes in which certain new substances formed, like the tea was formed, like the cheese was formed. So these all are chemical changes because you cannot reverse them. You cannot prepare milk, or you can say you cannot extract milk out of that cheese, or you cannot separate the sugar, water and the milk out of tea. You cannot do that. So chemical change is something in which certain new substances formed, right? And the changes are irreversible. We cannot reverse the change. And also the energy changes take place. Either we need to supply it with energy, or the chemical changes is accompanied by the release of energy. So energy changes also takes place. Right, so I think you got it, that what is the difference between the physical and the chemical change. Now in this chapter, we are going to focus on the chemical reaction and equation. So if I say chemical reaction, that means it is a chemical change. Here we are going to see that the chemical change takes place in a chemical reaction, right? So whenever there is a chemical change, that means chemical reaction is taking place. Now the question must be coming into your mind that what is chemical reaction? So just have a look on the board that how we are going to define it. Then I'm going to explain you. So chemical reaction is a process in which certain substances get mixed thoroughly and then the new substance is formed, right? So certain substances are mixed, right? So they get mixed thoroughly and we get a new substance. So that is called as chemical reaction. So in a chemical reaction, the substances which we mix initially, they are termed as reactants. And the new substance which is formed is called as product. So that means the chemical reaction involves reactants and the products. So reactants and the products will be there in every chemical reaction. No reaction can take place without the participation of reaction and product, right? So let me write a general expression of the reaction for you. For example, if I say A plus B forms C, I have A plus B, arrow denotes that they are combining and they are forming. And what they are forming? They are forming C. So in this reaction, A and B, they are called as reactants because initially those substances are reacting, right? And they are reacting and this arrow denotes that they form. And what they form? They form the product, that is the new substance, which is called as C, right? So A plus B forming C is a chemical reaction. But don't get confused by this, that don't think like that every time we need to have A and B, that means two reactants. The reactant can be one also. For example, I may have a reaction like AB, arrow means it is forming A plus B. So in this case, we have one reactant and we have two products. So reaction can be like this also, right? Moreover, we can say that the reactant can be 1, 2, 3 or many, and even if we focus on the product can also be 1, 2 or many. So that depends and varies from reaction to reaction. But in every chemical reaction, it is mandatory that we have reactants and we have the products. And the reactants are written on the left hand side and the products are written on the right hand side. So I think you got it that what basically is chemical reaction and how we are going to define that, and also you are aware of the reactants and products, and also you know about the meaning of this arrow, that what does arrow signifies. So I think the introduction part is clear. So now let's take up few activities in order to demonstrate or in order to make you understand that the chemical reactions are taking place in nature. So let's take up few activities. So let's start with the first activity, that is the popular activity which is called as burning of magnesium ribbon. And let me clear you that this activity is very important and you will get a question from this activity. So just listen to it carefully. So have a look on the board. So what you can see in this picture, we have tongs, right? And with the help of tongs, we are holding the ribbon sort of thing, and that ribbon is the magnesium ribbon, right? We have a burner, right? And we can light this burner, obviously, we can light it. And now what we are going to do is, we are going to burn this magnesium ribbon, right? But before burning, what we'll do is, this magnesium ribbon has a certain layer around it. Like when it comes in contact with air, it combines with oxygen and forms the carbonate layer. It combines with carbon dioxide and forms the carbonate layer on its surface. So that means the magnesium ribbon already has a deposit of magnesium carbonate layer. Now in this activity, we do not require magnesium carbonate, we require just magnesium. So what we have to do is, we have to remove this layer. And how we can remove it? We can remove it by rubbing it with sandpaper. So as you can see that we are rubbing this magnesium ribbon with the help of sandpaper. And why we are doing so? Because by doing so, we are removing the magnesium carbonate layer and we are getting the pure magnesium. Now let's burn it. So like with the help of tongs, we are holding it and we are burning it with the help of the burner. Now, as you can see that when we are burning this ribbon, we get a characteristic flame. There is a special flame that you can see, right? And that flame is called as dazzling flame. That flame is called as dazzling flame. Now, when you're burning it, you can see that a certain powder-like substance is falling down, and you can collect that substance in a dish, right? The substance which is formed is magnesium oxide. Obviously, if you are heating magnesium with oxygen, so that means magnesium is getting combined with oxygen, because no heating can take place where the supporter of combustion is not present. So obviously, for heating we require the supporter of combustion, and that is oxygen. So when you are heating it, the magnesium ribbon, or you can say just the magnesium, it combines with oxygen and give rise to magnesium oxide. And the color of magnesium oxide, as you can see here, it is white in color. And like, what is the form of magnesium oxide? Obviously, it has a powder form. So this chemical reaction takes place. Now, how MgO is formed? You know that. You have already learned about the valencies, you know about the radicals. So magnesium possesses +2 valency, and the oxygen possesses 2 negative valency. So when we combine magnesium with oxygen, that is a metal, because it possesses the positive valency, with the non-metal with the negative valency, then they will get crisscross, and as a result we get the compound with molecular formula MgO. That is the reason the equation involved in this case is Mg plus O2, giving rise to MgO, right? This is an unbalanced equation. This is an unbalanced equation. Now, I am not balancing it because we have not reached till the balancing part, so that we will do later. So at this moment, we are just studying about the activities. That is to show that chemical reactions are taking place in nature and how they take place, and what are the identification properties that make us familiar that yes, the reaction is taking place. So if somebody asks you about the burning of magnesium ribbon, or if somebody asks you about that if you burn magnesium ribbon, what kind of flame do you come across? So you should be ready with the answer that the flame is dazzling flame, right? And if somebody asks you about the color of magnesium oxide, so you should be quick with the answer that it is white in color. And if somebody asks you about the reaction, then what you are going to say? Obviously, we are going to write like this: Mg plus O2 forming MgO, which is magnesium oxide, right? So, two identification property of this burning of magnesium ribbon. One is the dazzling flame, and second is the formation of white powder like substance, which is none other than the MgO, that is magnesium oxide. So, I think you got it. So, let's move on to the second activity. So, the second activity what I have for you, just have a look on the board. So, that is the reaction of zinc granules with dilute sulfuric acid. So, if I talk about magnesium ribbon, if I talk about zinc granules, please don't get confused with the forms. Like if I use the word copper rod, copper coin, don't get confused with the type of object which I am using. We are just concerned with the composition, like it is made up of copper, or it is made up of iron, or it is made up of zinc. We are just concerned with the chemical constitution, that what exactly the substance is made of, right? So, moving on to this activity, that is reacting zinc granules with dilute sulfuric acid. So, let's talk about the apparatus first, that what do we actually have in this. So, you can see that we have the conical flask, right? This is called as the conical flask. We have put certain zinc granules into it. As you can see that these granular parts, these granules specifies the zinc granules. They are made up of zinc. Now, you can see that like on the upper portion, we have the cork present. We have the cork. In order to seal this can, we make use of this cork. Now, you can see that there are two pipes which are going inside the conical flask, right? And one pipe has a end which is opening at this point, and one pipe is the inlet pipe, you can say, through which we are putting the dilute sulfuric acid, which is H2SO4. Dilute means it has more amount of water content, right? So that means dilute H2SO4, acid with more water content. So sulfuric acid is poured dropwise into it. Right. So that means in this activity, the reaction is going to take place between zinc and the dilute sulfuric acid, which is H2SO4. Right. Now, what happened when we leave the apparatus like this, then after a certain period of time, what we see is that zinc and H2SO4 starts reacting. But how do we come to know that they are reacting? We can come to know by noticing certain features in this activity. That is, like when we are touching the conical flask from outside, we'll feel that the flask has become hot. It has become hot, right? And the second thing is, like we can say that there's an outlet pipe which is coming out. So if we bring the matchstick near this pipe, that matchstick starts burning. That means something is evolved from it. And obviously something might have escaped out just because both the reactant might have reacted together, right? They might have reacted with each other. So zinc and H2SO4, they react with each other, and the equation which is involved in it is zinc granules, that means Zn, plus dilute sulfuric acid, that means H2SO4 in dilute form, and what they are forming, arrow signifies that they are reacting and something is formed. Now what is formed? So the formation of zinc sulfate, ZnSO4 plus hydrogen gas, H2 is evolved. And this H2, we know that the gases are volatile. They have the property to escape. So H2 gas escapes out through this outlet pipe, and that is the reason when you are bringing the matchstick, it is lighted up. Reason being, hydrogen again is the supporter of combustion, and due to which we can see that the matchstick starts burning with pale blue flame and a characteristic sound, that is the popping sound, right? So this popping sound and the blue flame is the identification property, or you can say which actually confirms the presence of H2 gas. I think you got it. So if somebody asks you about this activity, that like what is the reaction which is involved? So obviously you're going to write like this: zinc plus H2SO4 forming ZnSO4 plus H2, right? And you can see that in this case I have put the upward arrow with the H2. That is just because it is indicating that H2 is a gas and it's a volatile in nature and it will escape out, right? Now, if somebody asks you about the hydrogen test, like if I ask you that yes, the reaction is taking place, and if I ask you that how you will show that this gas which is evolved is hydrogen, not carbon dioxide. So obviously we will have a test, and the identification test for the presence of H2 gas is that when we bring the matchstick near the outlet pipe or from any tube from which the gas escapes out, that matchstick starts burning. And the flame color is pale blue flame, and there is a characterized sound, and there is a characteristic sound, and that sound is the popping sound. So these two things confirms the presence of H2 gas, right? So another question that can be asked depending upon this activity. So they may ask you that write the two identification property of this activity which shows the reaction has taken place. So which two properties you are going to write? Obviously, we are going to specify that the first property, the conical flask becomes hot after some time, right? Initially it was not hot, but as they have reacted, so that is the reason it has become hot. That is the reason it becomes hot, right? Second is the hydrogen gas which is evolved. Right. So these two are the identification property. So I think you understood this property well, right? So let's move on to the third activity. So the third activity which I have for you is the reaction between barium iodide and lead chloride. Now just have a look that how I'm going to react them. So see, I have two flasks, right? In one of the flask, I have barium iodide, right? And in the another flask, I have the lead chloride. Now, what I'll do is, I'll just mix them. As you can see that we are mixing it. So when you mix both the content of the flask, that is the barium iodide with lead chloride, right, you can see that there is the certain formation of insoluble substance in the beaker that you can see here, right? So that substance which is formed, that insoluble substance that is formed, that is called as precipitate. This is a general term which we use for any insoluble substance. And if somebody asks you about the reaction which is taking place, so you can write in a simpler manner that we have barium iodide, which is BaI2, right? Plus, that means you are reacting. And the second component, the second reactant what we have is lead chloride, which is PbCl2, right? Arrow signifies that they are reacting and they are forming something. Now what they are forming? So we have the barium iodide reacting with lead chloride. So we'll get the barium chloride, which is BaCl2, plus lead iodide, which is PbI2. And this yellow color which you can see inside the flask, the yellow color insoluble substance, that is the precipitate, that is of PbI2, that is lead iodide. So I think you got it. So this is the the evidence for the chemical reaction, that yes, the chemical reactions are taking place in nature or around us. So if somebody asks you about that, how you can show or how you come to know that the reactions are taking place. So we can make out that the reactions are taking place by taking into consideration few characteristics of the chemical reaction, right? So the first characteristic of chemical reaction is that it is either accompanied by a change of color, right? You may see that there is a change in color, like initially the reactants of any other color, and when a product is formed, it is of certain different color, right? So the change in color can be one of the identifying feature which shows that the chemical reaction takes place. The second is the heat changes that occur, because the heat may be absorbed or heat may be evolved as a result of chemical reaction. So heat changes also shows that the chemical reaction occur in nature. And in certain reaction, you may come across that certain insoluble substance, that is precipitate, is formed. As we discussed, in the previous activity, lead iodide precipitate was formed, that is the yellow color precipitate. So that also shows that initially the precipitate wasn't there, but when the both substances were mixed, they lead to the formation of this precipitate. So that signifies that the chemical reaction takes place in nature. And now in the few reactions, we'll come across that the gas is formed. Like we did the activity where the zinc granules reacted with the dilute sulfuric acid. What we noticed? We noticed that the hydrogen gas was evolved, right? So the gas might evolve, right? So these are the certain characteristics that we see in the chemical reaction, and through these changes which we notice, we can make out that the chemical reactions are occurring and they take place, right? So I think you are clear about the characteristics. So let's sum up all the characteristics that we can see in a chemical reaction. So there can be a change in color, there can be a change in state, because the state might change. For example, if I react hydrogen with oxygen, hydrogen is a gas, oxygen is gas at room temperature. So when you react H2 and O2, what do we get? We get water, but water is liquid. So that means here the state of product is something different if we compare it with the state of the reactants. So there can be a change of state also. There can be the evolution of gas, that is the gas is evolved. There can be formation of insoluble substance, that is precipitate, and it may the reaction may absorb or release heat depending upon its nature. So these are the few characteristics which actually shows that the chemical reaction takes place around us.